In our modern world, we build with steel, concrete, and incredible precision machinery. We tend to fight against nature, dominating it to raise our skyscrapers and span our bridges. But what if the greatest wisdom wasn't in fighting nature, but in working with it? What if the most resilient structures weren't rigid, but flexible? For thousands of years, ancient China built an empire of wood, creating architectural marvels that have outlasted dynasties and withstood some of the planet's most violent forces. And they did it all without the technology we take for granted. Imagine your job is to build a palace that will last 1,000 years, and it has to survive the violent fury of an earthquake. Now, imagine you're told you can't use a single nail, screw, or metal bolt. Sounds impossible, right? And yet, for centuries, ancient Chinese architects did just that. This is the story of how they built the impossible, not by fighting the forces of nature, but by learning to dance with them. Section 1. The philosophical core. To understand how they built, you first have to understand how they thought. At the heart of ancient Chinese philosophy, in both Confucianism and Taoism, is the principle of harmony between humanity and nature. They believed people weren't separate from the natural world, but part of a single, unified whole. This wasn't just poetry, it was a blueprint for engineering. Western architecture often tries to achieve permanence through rigidity. Think of the unyielding stone castle or the rigid steel frame. But ancient Chinese builders saw wisdom in the bamboo that bends in the wind, while the mighty oak cracks under the same strain. They saw strength in yielding, in flexibility, and in balance. This philosophy shaped everything, from the layout of entire cities to their choice of materials. Wood was a favorite, not just because it was available, but because it was seen as a living, breathing material connecting a home to the natural world. Stone, by contrast, was often reserved for tombs. This deep-seated belief that buildings should coexist with nature led to a series of engineering masterstrokes that still impress engineers today. It all starts with the very skeleton of the building. Section 2, Secret 1, the flexible skeleton, mortise and tenon joints. So, how do you build a multi-story wooden pagoda or a sprawling palace without a single nail holding it together? You turn the wood itself into a series of intricate, interlocking puzzles. This is the art of mortise and tenon joinery. The concept is elegantly simple. On one piece of wood, you carve a peg, called a tenon. On another, you carve a perfectly matching hole, the mortise. When you fit them together, the joints create an incredibly strong and stable connection, purely through the precision of their shape. This wasn't a simple, one-size-fits-all solution. Ancient carpenters developed a huge vocabulary of joints, with hundreds of variations designed for different angles and to handle different kinds of stress. There were dovetail joints that locked tighter under tension and complex wedged joints for securing massive beams. This technique, which dates back thousands of years, required an incredible level of craftsmanship. Each joint was hand-carved with such accuracy that the pieces fit together seamlessly, creating a structural frame that was immensely strong. But its real genius wasn't just its strength, it was its built-in flexibility. Unlike a nailed or welded joint, which is rigid and brittle, a mortise and tenon joint has a tiny amount of give. It allows a wooden frame to move and settle without breaking. During an earthquake, this network of hundreds of joints can flex and absorb energy, preventing the catastrophic failure of any single point. This created a building that wasn't a static object, but a flexible skeleton, able to move with the forces of nature. But these joints alone couldn't support the immense weight of the iconic, sweeping roofs of Chinese architecture. For that, they needed something even more ingenious. Section 3, Secret 2, the earthquake absorber dugong brackets. If you look up at the eaves of any traditional Chinese temple or palace, you'll see what looks like an elaborate cascading flower of carved wood blossoming from the top of each column. This is the dugong bracket system, and it's arguably the single most important element of ancient Chinese architecture. The name itself, du, block, and gong, bow-shaped arm, describes how the pieces are interlocked, layer upon layer, without any nails or glue. On the surface, the dugong has a clear purpose to support the massive, heavy roof and transfer its weight down through the columns. The interlocking arms also allow for those beautiful, overhanging eaves that protect the wooden structure from rain. But its main function is far more brilliant. The dugong is a masterfully engineered seismic shock absorber. When an earthquake strikes, a rigid structure fights the shock waves, which leads to stress and collapse. A building with dugong brackets, however, does something extraordinary. It moves times with times the quake. The many individual pieces of the dugong cluster are designed to shift, rob, and rotate against each other. This movement and friction dissipates the seismic energy, essentially absorbing the earthquake's punch before it can shatter the main structure. It's a process of energy dissipation that modern engineers now use in advanced damping systems for skyscrapers. The Forbidden City, for instance, has survived over 200 recorded seismic events in its 600-year history, largely thanks to this incredible system. In a modern experiment, engineers built a precise 1:5 scale model of a hall from the Forbidden City and put it on a shake table. It withstood a simulated magnitude 10.1 earthquake stronger than any quake ever recorded. Section 4. Secret 3. The floating foundation. The secrets of this earthquake-proof system go all the way to the ground. After creating a flexible wooden skeleton and a shock-absorbing roof system, the final piece of the puzzle was how the building met the earth. And here, ancient builders used a solution that seems completely counterintuitive. If you were to inspect the massive columns of a palace hall, you'd expect them to be buried deep in a concrete foundation. But they aren't. In fact, the wooden columns often just sit right on top of stone plinths, with nothing holding them in place. The entire building essentially floats on its foundation. This wasn't an oversight, it was a brilliant design choice. First, placing the wood columns on stone bases protected the timber from ground moisture and rot, dramatically extending the life of the structure. But its real purpose is revealed during an earthquake. Because the columns aren't rigidly anchored, the whole timber frame is able to slide slightly on its stone bases when the ground shakes. Instead of the Earth's violent motion shooting straight up into the frame, the building is allowed to skate on its foundations, isolating it from the most destructive vibrations. This trinity of engineering, the flexible joints, the dugong brackets, and the floating foundation created a structure that could effectively dance with an earthquake. But there was one final, shocking secret to their design. Section 5. Secret 4. The sacrificial walls. In almost all modern construction, the walls are what hold the building up. They are load-bearing and essential to the building's integrity. In traditional Chinese timber frame architecture, the exact opposite is true. The walls held up nothing. The entire weight of the building was supported by the internal skeleton of columns and beams. The walls, often made of brick, rammed earth, or lattice, were just partitions. They were there to divide spaces and provide shelter, but they carried no structural load. This had a revolutionary consequence. During a severe earthquake, the walls were basically designed to crumble and fall away without affecting the main structure. This sounds destructive, but it was a life-saving measure. The collapse of a heavy, non-structural wall is far less dangerous than the collapse of the entire building. By sacrificing the walls, the core timber frame where people would be sheltering was protected. It helped ensure the main structure would remain standing, allowing occupants to survive. This idea of designing certain parts to fail in order to save the whole is another principle that modern engineers now use in everything from cars to spacecraft. It reveals a profound systems-level approach that prioritized human life above all else. The flexible skeleton of mortise and tenon joints, the shock-absorbing dugong brackets, the floating foundation, and the sacrificial walls all worked in harmony. They created not a static monument, but a living structure designed to bend, flex, and move with the forces of nature. This ancient wisdom was born from a deep respect for the natural world, a belief that true strength comes from harmony, not opposition. Today, as we face new challenges in building sustainably and protecting our cities from natural disasters, engineers are looking back at these ancient techniques for answers. They are studying the physics of the dugong and the flexibility of timber frame construction, recognizing a genius that was perfected thousands of years ago. The master builders of ancient China left behind more than just beautiful palaces and temples. They left a legacy of ingenuity and a timeless lesson written in wood. The greatest structures aren't those that fight the world, but those that learn to dance with it. If you thought these building techniques were impressive, wait until you see the ingenious military technologies and siege weapons developed in ancient China. We're exploring that next, so make sure you're subscribed so you don't miss it.